Good morning, students. So today I'm taking the class for Bsc second semester, that is polar coordinates and polar curves. So I have already sent the syllabus of Bsc second semester through Google Classroom. So I hope that all Bsc second semester students have downloaded the syllabus. So let us start polar coordinates and polar curves. So what are polar coordinates? So polar coordinates means these are the coordinates which are used to locate a point P in a plane. So that is, you know what is Cartesian coordinate system. So Cartesian coordinate system means what? It is a system which is used to locate a point P in a plane. So, and those are called as XY coordinates. Okay. So you take one point on X and you take another point on Y, and then you draw some perpendicular line on both of these lines. Then where these lines intersect each other, so that is the corresponding point of these two coordinates. Okay, so in the same way, this is polar coordinates are used to locate a point P in a plane, and the system is known as polar coordinate system. So here, consider a point P in this plane, consider a point P in the XY plane. Then this is x-axis and this is y-axis, and these two x-axis and y-axis intersect at this point, and this is known as origin. Okay, so call this as O. Then join the point O and P. Okay, join O and P, and let R be the length of this line OP. Okay, and next let the line OP makes some angle with x-axis, that is theta. Next, draw a perpendicular line from the point P on x-axis. Okay, and that is Y. Okay, so now this R and theta. So here this is the length of the line OP. R and theta are called as the polar coordinates of the point P. So that is, these two coordinates, that is R and theta, they are responsible for finding the position of a point P in a plane. So as you observe that, as you increase or decrease this length R, okay, if you increase or decrease this length R, then you get a different position of the point P along this line. Okay, so if you increase R, okay, and in the same direction, so you will get point P at somewhere here. Okay, and if you decrease this R, okay, if you decrease up to this one, then you may get a point P, position of a point P at somewhere here. Right? And similarly, if you change the angle, theta, then again you will get different position of the point P. Suppose if theta is, say if you take theta as 90 degree, then this line coincides with this y-axis, and the point may, the position of the point P lies on y-axis at somewhere here. Okay, similarly if you take theta is equal to 120 degree, means what happened then, if you take theta is equal to 120 degree, then this line comes at this point, okay, at this point, and the point P lies at somewhere here. So as you change this R and theta, you will get different positions of the point P in a plane. So therefore this R and theta are called as the polar coordinates of the point P. And here this R is known as the radial distance. And this theta is known as the polar angle. And here the origin O is called as the pole. And the x-axis is called as the initial line. Okay, so this is about polar coordinates. Next, we take the relation between Cartesian coordinates and polar coordinates. So, when we want to convert Cartesian form to polar form, then we take x is equal to r cos theta and y is equal to r sin theta. We substitute x equal to r cos theta and y is equal to r sin theta in the given equation. So then that equation converts it into a polar form. Okay, so when we want to convert polar form to Cartesian form, then we use these equations. So that is r is equal to square root of x square plus y square and theta is equal to tan inverse of y by x. So these equations we use for converting polar form to Cartesian form. So how these relations are obtained? Just now say this is one right angled triangle, this is a right angled triangle, and this is the angle theta. Now from this equation calculate the sin theta. So sin theta is nothing but what? Opposite by hypotenuse. So sin theta is y divided by r. So y by r is equal to sin theta. Cross multiply, you will get y is equal to r sin theta. Similarly, cos theta. Cos theta is nothing but what? Adjacent side by hypotenuse. So adjacent side is x, hypotenuse is r. So cos theta is equal to x by r. Cross multiply, then x is equal to r cos theta. So you will get. Okay. So these are the relation between Cartesian coordinates and polar coordinates. Next we derive angle between the radius vector and the tangent. Okay. So here let r is equal to f of theta be a polar curve. Okay, let r is equal to f of theta be a polar curve, and then let the angle between the radius vector and the tangent is be phi. Okay, so now what we have to show? Tan phi is equal to r into d theta by dr. So this is the equation for angle between the radius vector and the tangent. Okay, so here this is a polar curve. Now see, this is a polar curve and it is given by the equation r is equal to f of theta, right? And then this is a point P of r theta. This is a point P on this curve. Then join O and P. So this is the radial distance, that is r, and this is the angle theta. Okay, so made by this line with the initial line or x-axis, right? Now take the tangent at this point P. So now this is the tangent at the point P to the given curve r is equal to f of theta. Okay, so now let psi be the angle made by this tangent with this x-axis. So this is the psi is the exterior angle, right? So now from this equation, now what we do? We take let p of r theta be any point on this curve, r is equal to f of theta, and then let this t be the tangent to the given curve. Then let this tangent makes angle psi with this x-axis. Okay, we write all these things, and then from this equation, now so this is the psi is an exterior angle, and from the geometry we know that exterior angle is equal to sum of the interior angle. So now this angle is not given. So let this angle be phi. Okay, as you have taken here phi. So these are opposite cones, these are opposite angles. So always opposite angles are equal. So if this is phi, then this is also phi. Okay, so now this is these two are interior angles. So one interior angle is theta, and this is another interior angle. So that is phi. Okay, so now this exterior angle is equal to sum of the interior angle. So therefore we write psi is equal to theta plus phi, theta plus phi. So then r is equal to f of theta is given by polar coordinates. So put x equal to r cos theta and y is equal to r sin theta. Then we differentiate with respect to theta. So we differentiate with respect to theta. So that is dr by d theta is equal to. So we differentiate this with respect to this is dx by d theta. Differentiating this with respect to theta, that is dx by d theta. Okay, this should be x. Okay, make the correction. So dx by d theta is equal to. So while differentiating with respect to theta, we apply product rule, right? So first r as it is, differentiation of cos theta is minus sin theta, then plus this cos theta as it is, then differentiation of r with respect to theta dr by d theta. Similarly, we differentiate this equation y with respect to theta. So dy by d theta is equal to, again we apply product rule, r first function as it is, differentiation of sin theta is cos theta plus sin theta as it is, differentiation of r dr by d theta. Okay. So after obtaining this one, next we know that from the trigonometric identities, tan phi is equal to tan psi minus theta, because now see, this is psi is equal to theta plus phi. From this equation we calculate phi. So phi is equal to psi minus theta. So phi is nothing but what? Phi is the angle between the radius vector and the tangent. So phi is the angle between the radius vector and the tangent. So that we have to find. Okay, we have to find the expression for phi. So therefore, what we do, from this expression we take out phi. So that is phi is sin minus theta. So tan phi, applying tan phi is equal to tan of sin minus theta. Then apply tan a minus b formula. So it is tan psi minus tan theta divided by 1 plus tan psi tan theta. Now call this equation as 3. So this is equation 1. So we convert Cartesian to polar form. So this is equation 1, and we differentiate this x with respect to theta and differentiate y with respect to theta. So call this equation as 2, and then taking out phi from the formula, then tan phi is equal to tan of psi minus theta. Apply tan a minus b formula and we'll get this one. So this is equation 3. Now since the tangent line to the curve, so this after getting this one, again we know that tan psi is nothing but what? Tan psi is equal to, tan psi is nothing but slope of the tangent. Okay, so slope of the tangent is given by tan psi, or a slope of a curve is given by dy by dx, right? So dy by dx. So to find out dy by dx, since dy by dx can be found by dividing dy by d theta by dx by d theta, right? So dy by dx can be obtained by dividing dy by d theta by dx by d theta. So we divide both dy by d theta divided by dx by d theta. Okay, so we will get tan psi. So therefore tan psi is equal to dy by d theta by dx by d theta. Okay, so now substituting this tan psi in this equation 3. Okay, in this equation 3. Okay, so then we get tan phi is equal to, next tan psi is dy by d theta by dx by d theta minus tan theta. So tan theta, again by converting into Cartesian to polar to Cartesian form, so tan theta is y by x. Okay, because theta is tan inverse of y by x, so tan theta is y by x divided by this 1 plus tan psi is dy by d theta by dx by d theta. Again tan theta is nothing but y by x. So which is equal to, again here taking LCM and simplifying all this, you will get x dy by d theta minus y dx by d theta, and divided by x dx by d theta plus y divided by d theta. So now x into, write dy by d theta here. So this is dy by d theta. I will do calculated dy by d theta. So this is dy by d theta. Okay. Now substitute this dy by d theta here. So here dy by d theta. Next y minus y. Again we have found dx by d theta. So this is what dx by d theta. So substitute this dx by d theta here in this equation. Divided by same x into dx by d theta, then plus y into dy by d theta. Okay. So again after simplifying, and here we get r cos theta. We take r cos theta common from this term, and then again r cos theta from the denominator also. What we do is substitute x equal to r cos theta, y is equal to r sin theta. Again x is equal to r cos theta and y is equal to r sin theta. So okay, we will get this equation. Then simplifying, some terms will be cancelled. Okay, some terms will be cancelled. So like here r square in r cos theta into r cos theta becomes r square cos square theta, right? Then plus minus into minus becomes plus r square r sin theta into r sin theta, r square sin square theta. Now in these two terms r square is common, and we provide cos square theta plus sin square theta is left, so that is equal to 1. So only r square is okay. Then multiply these two. So this is r cos theta sin theta dy by d theta. Then again here multiply this into this minus r sin theta cos theta dy by d theta. So these two will cancel each other. Okay. Only one term it will be left in the numerator. So that is r square divided by again here the first terms, that is minus r cos theta r square cos theta sin theta, then plus here again r square cos theta sin theta. So these two will cancel each other. And in the second term, so when you multiply these two, you will get r cos square theta dy by d theta plus in the second term again r sin square theta dy by d theta. So in both the terms you take r dy by d theta common, and in bracket you left with the sin square theta plus cos square theta. Again it is equal to 1. So r dy by d theta is left in the denominator. So therefore what we get, tan phi is equal to 1r get cancelled. So r divided by dy by d theta. Or in other words, tan phi is equal to r into this comes in the numerator and it will be reversed, that is d theta by dr. So therefore tan phi is equal to r into d theta by dr. So this is the derivation for angle between the radius vector and the tangent. So to find the angle between the radius vector and the tangent, we use this formula. So for any given curve, they will give some curve. Either they may give the polar form r is equal to into 1 plus cos theta, or they may give some other type of polar curve. Then if you want to find the angle between the radius vector and the tangent, so we use this formula. Okay, so first we find this tan phi is equal to r into d theta by dr. Now see here this phi is the angle between the radius vector and the tangent. Okay, so then for example, take one example. Find the angle between the radius vector and the tangent to the curve r is equal to a into 1 plus cos theta at theta is equal to pi by 6. Right? So this is the given problem. Here what we have to find? We have to find angle between the radius vector and the tangent to the curve. So this is one type of curve. Okay, r is equal to a into 1 plus sin theta. This is one type of curve. And for that curve, we have a tangent to that curve, and then we find the angle between the radius vector and the tangent. So given curve is r is equal to a into 1 plus sin theta. Now taking log on both the sides, apply log on both the sides. So we will get log r is equal to, now here it is ab. So log ab is log a plus log b. So that is log a plus log 1 plus sin theta. Next, differentiating with respect to theta. Differentiate this with respect to theta. So while differentiating log r apply chain rule. First we differentiate log r. So differentiation of log r is 1 by r. Again differentiating r with respect to theta dr by d theta, which is equal to, now this a is constant, so log a is also constant. So differentiation of log a is 0 plus this log of 1 plus sin theta. Differentiating log of 1 plus sin theta we will get 1 by 1 plus sin theta. Now again differentiating chain rule, applying chain rule, differentiation with 1 plus sin theta, it gives cos theta. So we get now this can be written as r into d theta by dr is equal to 1 plus sin theta by cos theta. Okay, so just we have reversed this. So this is 1 divided by r into dr by d theta. Now reverse this. So this gives r into d theta by dr. Now this is equal to this, means this is also reversed. So 1 plus sin theta divided by cos theta. So now by the formula, this is nothing but tan phi. Okay, angle between the radius vector and the tangent. So this is nothing but the tan phi. So tan phi is equal to 1 plus sin theta by cos theta. Okay, so now we have to find the angle between the radius vector and the tangent at what? At theta is equal to pi by 6. So this is given. So in this case what we do, we substitute theta is equal to pi by 6 here, which gives tan phi is equal to 1 plus sin pi by 6. So pi by 6 means it is 30 degree. So sin 30 degree is 1 by 2 divided by cos theta means pi by 6. Cos 30 degree again it is root 3 by 2. Okay, so this is root 3 by 2. So now after simplifying, tan phi is equal to, this gives 3 divided by root 3, or will cancel each other, then it gives root 3. 3 can be written as root 3 into root 3. So 1 root 3 get cancelled and it gives root 3. Or phi is equal to tan inverse of root 3, which is 60 degree, or phi is equal to pi by 3. So this is the angle between the radius vector and the tangent. Okay, another method you can have, you differentiate directly, you can differentiate, no need to take log. Okay, so this is one method, by taking log on both the sides. Another method you can do, directly differentiate this, okay, without taking log, find out dr by d theta, okay, then reverse it, you will get d theta by dr, then multiply r on both the sides, you will get r into d theta by dr. So then again simplify and you will get again same answer you will get. Okay, so in any way you can solve this problem either by taking log or by directly differentiating the given equation r. Okay, so this is the first problem. In the same way we solve the second one. Find phi. Phi means again angle between the radius vector and the tangent for the curve r is equal to a into 1 minus cos theta. Now given curve is r is a into 1 minus cos theta. Now taking again log on both the sides as you did in the last problem. So log r, this is log a plus log 1 minus cos theta, differentiating with respect to theta and you will get this equation. Then reverse this, then you will get this equation. So then this becomes tan phi, which is equal to, now in this case we have to simplify. So here 1 minus cos theta can be written as 2 sin square theta by 2 by the trigonometric identities. Okay, by trigonometric identities 1 minus cos theta can be written as 2 sin square theta by 2 and sin theta can be written as 2 sin theta by 2 cos theta by 2. So in this case 1 sin theta by 2 and 1 sin theta by 2 get cancelled and 2 get cancelled. So and what remains? 1 sin theta by 2 in the numerator and 1 cos theta by 2 in the denominator. So sin theta by 2 cos theta by 2 is tan theta by 2. So here we get tan phi is equal to tan theta by 2. So both tan will get cancelled. So phi is equal to, you will get theta by 2. So this is the angle between the radius vector and the tangent for the given curve r is equal to a into 1 minus cos theta. Okay. Again this is also same, find the angle between the radius vector and the tangent to the curve r is equal to a into 1 plus cos theta. Same method you have applied, taking log on both the sides, then differentiate with respect to theta, reverse it, you will get tan phi. Then again 1 plus cos theta you have to write minus 2 cos square theta by 2 and sin theta is again 2 sin theta by 2 cos theta by 2. 1 cos theta by 2 cos theta by 2 get cancelled, 2 get cancelled and you will get cos theta by 2 by sin theta by 2, which is cot theta by 2. Now to get phi, tan phi is equal to, now minus cot theta by 2 is same as tan of pi by 2 plus theta by 2, right? Because tan pi by 2 plus theta by 2 is same as, because it comes in the third quadrant, pi by 2 plus in the in the second quadrant. In the second quadrant only sign is positive and all others are negative. So therefore this tan, and it is even odd multiple of 90, so tan changes to cot, so cot theta by 2 with minus sign. So both the sides tan will get cancelled, so phi is equal to pi by 2 plus theta by 2. So this is the angle between the radius vector and the tangent. Okay, so similarly we find the angle between the radius vector and the tangent to the curve r square is equal to a square cos 2 theta at theta is equal to pi by 6. Okay, same thing, you have to take the given equation r square is equal to a square cos 2 theta, apply log on both the sides. Okay, so you will get log r square. So log r square is nothing but 2 log r. So that is log m raised to n can be written as n log m. Okay, so in the same way 2 log r, and then this is log ab, log a plus log b. So log a square plus log cos 2 theta. Again differentiating with respect to theta, and you will get this equation. Then you will get r d theta by dr is equal to minus cos 2 theta by sin 2 theta. Then reverse it, you will get tan phi is minus cot 2 theta. Then substitute theta is equal to pi by 6, because we have to find the angle between the radius vector and the tangent at theta is equal to pi by 6. So substitute theta is equal to pi by 6 here, you will get tan phi is minus cot 2 into pi by 6. Then pi by 6 means 30 degrees, so this gives cot 60 degree. So cot 60 degree is minus 1 by root 3. Or tan phi is minus tan pi by 6, or tan will get cancelled. Phi is equal to this is tan of pi minus pi by 6, because minus tan of pi by 6 can be written as tan of pi minus pi by 6. Tan get cancelled. Phi is equal to pi minus pi by 6, or simplifying this you will get phi is equal to 5 pi by 6. So this is these are the problems regarding the finding the angle between the radius vector and tangent to the curve by using the formula r d theta by dr is equal to tan phi. Okay, so with this I conclude this session, and I'll continue in the next class. Thank you.